I'm Mr. Ish and I'm welcoming you to this video. Many of you in high school would probably know basic derivatives because now that has become the norm. Especially in 11th and 12th grade, many students around the world end up learning basic polynomial derivatives. And this tip with regards to that can help you out quite a bit. We're talking about straight line motion or motion in a single dimension. If you're given the position function, you can do its derivative and arrive at the velocity function. You can do the derivative of that and arrive at the acceleration function. This right here is a very important chain of events that you should be aware of. Everything is going in terms of a derivative, which tells you that the velocity function is a first order derivative with respect to the position. The acceleration is a second order derivative with respect to your position function, or a first order derivative with respect to your velocity function. But you don't have to be so technical. Just remember, if you are given the position function, you do its derivative with respect to time, you arrive at the velocity function. If you do its derivative, you arrive at the acceleration function. How can you put this in perspective? Imagine you're given a position function which looks something like this. You can either do t, or here you can do x or t variable. You can interchange them if you want. Imagine you're given an equation which is t squared minus 3t plus 5. This is your position function. And someone were to ask you to find the velocity at time 5 seconds, velocity at time 5. Now what do? Well, convert this very easily into a velocity function by doing its derivative. If you know basic polynomial derivatives, you can easily do this. T squared becomes a 2t, this right here becomes a 3. So now you have to evaluate velocity at time 5 seconds. You're just doing v at 5, which is basically 2 times 5 minus 3. You're getting a 10 minus 3, which is 7 meters per second. And that right there is very easy. Now supposedly someone told you to evaluate the acceleration at time 3 seconds. Well, now you need an acceleration function. Well, you do the derivative of this, you do the derivative of that, you arrive at the acceleration function. But the derivative of this is basically just a 2. There's no variable. You can't do acceleration here with a variable coming in. It's still going to be 2. Why will that be the case? Because this right here is no different than you looking at y equals 2, a horizontal line. At any point on this horizontal line, your acceleration is always the same. It's 2 meters per second square. But you're seeing how this tip comes in very handy. Essentially, you're seeing that the position function is a parabolic or a quadratic function, or a curve if you were to graph it. Then this right here, the velocity has become a linear function or a linear curve, a linear line, and then this right here has become a horizontal line. In essence, what you're seeing, everything is decreasing by an order or a degree of exponent of 1. Here you have a square, here you have a 1, and here you have a 0. You can see this very clear trend come into play. But remember, the essence of this video here is this right over here. If you're given the position function and you know how to do derivatives, go to the velocity function by the derivative of that. Then go to the acceleration function by the derivative of the velocity function. And you are given questions based off that. You are very quickly arriving at these necessary equations you need to answer those questions. But remember this tip, and we're only talking here about derivatives. Thank you for watching. Have a good day.